Elon Musk does not hesitate to invest in the most advanced technologies for Tesla's factories, provided they are genuinely useful, and the Giga Press is the most practical machine he has ever introduced at Tesla. Although it is anything but cheap, Tesla's progress today is, without doubt, due in no small part to the Giga Press, the game changer that lets Tesla mold major car structures in mere seconds. Those machines you have heard about so far, the 6,000-ton and 9,000-ton presses, are impressive enough, yet the upcoming 50,000-ton Giga Press will be even more astonishing, capable of turning out a dozen cars in only 60 seconds. Elon Musk has confirmed this and believes new models will slide straight into this gigantic machine, creating a production rhythm so intense that no human can safely get close. So how can a Giga Press build 12 cars every minute? Could this be the breakthrough for the next generation of vehicles? Let's dig in right now. You might not realize it, but the history of Elon Musk and the Tesla Giga Press is quite dramatic. Bringing such a behemoth into the company was anything but simple. The original spark, we're told, came when Musk noticed a die-cast toy car on his desk and asked, "Why can't we do exactly the same thing with real cars?" He quickly grasped that casting huge sections, like an entire Model Y underbody, could slash weight, cost, and assembly time in one move. At the time, Tesla was under fierce pressure to ramp up Model Y output, and trimming costs was critical. The Giga Press seemed like the golden ticket because it promised up to 40% savings on frame manufacturing alone. Yet no one in the automotive world had ever built a die-casting machine anywhere near this scale, so established suppliers were skeptical. Back then, automakers typically stamped steel sheets and welded hundreds of parts with robots, slow, complex, and costly. Undeterred, Musk reached out to 6 major die-casting companies about creating such a monster press. 5 dismissed the idea outright as unworkable. Hope dwindled, until Idra, an Italian specialist, finally said maybe. For Musk, that maybe was huge. Tesla then worked side by side with Idra for more than a year. Tesla's engineers kept asking for tweaks, Idra's crew kept revising blueprints. Eventually, they succeeded. Tesla's very first 6,000-ton Giga Press cranked out Model Y rear chassis castings. Next came the 9,000-ton version devoted to Cybertruck parts. Now Musk is ordering a 50,000-ton Giga Press for the Cyber Cab chassis and the affordable Model 2. Compared with the earlier presses, this new Titan is vastly more productive, able to cast multiple frames in one shot and cut casting time from about 70 seconds to roughly 5 seconds. Yes, that sounds unbelievable, yet the data is real. Musk himself remarked, "I think it'll build a car in under 5 seconds, imagine a complete car every few heartbeats." Then he laughed and said, "Sure, why not go to 50,000 tons? Just how big is this contraption? How long will it take to assemble? How does it outrun the already mighty 6,000-ton and 9,000-ton versions? And what sort of engineering magic allows it to spit out one Cyber Cab body every 5 seconds, 12 per minute?" These were the questions buzzing through everyone's mind when Musk first revealed the colossal press. Many people mix up the tonnage rating with weight, yet 6,000 tons, 9,000 tons, or 50,000 tons actually refer to clamping force, not mass. Even so, the machine itself is enormous. Estimates put the 50,000-ton press's mass at well above 3,000 tons, about 6.6 million pounds. For reference, a 6,000-ton press weighs around 430 tons, and a 9,000-ton press around 688 tons. By simple scaling, the 50,000-ton version could push past 8 million pounds, a true leviathan. Its footprint is staggering, roughly 131 feet long, 42 feet wide, and 39 feet tall, like a 4-story building tipped on its side. Tesla will need a specially reinforced facility, with deep concrete foundations, just to support the load. Remember, the 6,000-ton press is already 64 feet long and 17 feet high, so this larger sibling will dwarf it. How does it operate? In short, giant rams slam molten aluminum into a mold at ultra-high speed and equally high pressure, ensuring the metal fills every tiny corner with no voids or bubbles. Precision cooling must kick in instantly. Too fast and you trap gases, too slow and the metal cools before the mold fills. Afterward, a robot extracts the part, trims flash, and sends it through automated inspection. Casting a single huge component instead of welding dozens brings lighter weight, stiffer structure, and reduced labor. No wonder other automakers, General Motors, Hyundai, Volvo, Zeekr, Xpeng, and many others, are now chasing large-scale casting. Xpeng has even ordered a 16,000-ton press. Yet Tesla's 50,000-ton monster remains peerless. The base sequence stays familiar. Tesla melts fresh aluminum ingots along with leftover trimmings in a natural gas furnace at around 850 degrees Celsius. The molten metal transfers through heated pipes into a holding furnace kept between 750 degrees Celsius and 850 degrees Celsius. Nitrogen gas blankets the surface to stop oxide formation. Operators stir in argon gas through a rotary degasser, and filters catch particles down to 25 microns. Before each shot, robots spray a fine soybean oil mist, about 35 milliliters, on the mold to ease release, like greasing a baking pan. A vacuum clears trapped air. Then a high-speed piston injects the metal into the cavity. The piston itself gets a quick 8 milliliter oil squirt each cycle to keep things smooth. After injection, the casting stays clamped while solidifying, then ejects at roughly 400 degrees Celsius, plunges into a cooling bath to drop to about 50 degrees Celsius, hardening the alloy swiftly and improving strength. The mold then cools to about 185 degrees Celsius and is scrubbed clean for the next cycle. The entire loop, from shot to shot, can now restart in as little as 5 seconds for the new press, whereas earlier models took well over a minute. One big hurdle is keeping the mold halves from bursting apart under incredible pressure, so clamp force must be immense. With a 50,000 ton rating, the clamping force is mind-boggling. Musk says Tesla had to design ultra-fast cooling channels, an intelligent eject system, and AI-driven inspection to cope with the speed. No other automaker has attempted such an integrated solution. The approach turns car building into something resembling consumer electronics fabrication, compact, lightning-fast, and heavily automated. Where an older Model Y body line used about 1,000 robots, the redesigned line can get by with roughly 300. Productivity soars, expenses plummet. Plenty of critics once laughed at giant castings, they predicted aluminum molds would wear too quickly, offsetting any gains. Musk and Tesla have proved the opposite. Ford, Hyundai, Toyota, GM, and Volkswagen have all ordered presses after seeing Tesla's saving in time and money. Producing 12 vehicles each minute, 720 per hour, redefines automaking, matching Musk's plan for Model 2 volume to surpass even combined Model Y and Model 3 output. Meanwhile, competitor adoption lags, most rivals are only now experimenting with 6,000-ton presses. On a separate note, Waymo recently paused some autonomous taxi operations in parts of Los Angeles and San Francisco after violent protests linked to immigration policy crackdowns. Several Waymo vehicles were vandalized, and at least one was burned, releasing toxic battery fumes and forcing police to caution residents away from downtown. Damage estimates run up to $200,000 per vehicle. Tesla's own robotaxi service, by contrast, appears close to launch in Austin. A recent short clip on X shows a completely driverless Tesla robotaxi cruising city streets, with a public unveiling slated for the 12th of next month. Tesla seems confident that system reliability is finally high enough to expand testing beyond a handful of users. In other developments, Tesla's Model Y retained its rank as China's top-selling SUV in May, registering 24,770 units, edging past BYD's Song Plus at 24,240 and Geely's gasoline-powered Xingyue L at 21,014. Despite a 71% drop in Q1 profit, Tesla still moved 126,643 Model Y units in China during the first 5 months of 2025, beating the Song Plus tally of 110,551. Even so, May's overall Tesla sales were down 30% from last year, partly due to early-year Model Y production changes. Analysts expect stronger figures in Q3 and Q4. What Tesla is doing with the Cyber Cab is not just about deleting steering wheels and pedals, it is redefining how a car is built. Think of it as building with ready-made blocks, pre-built modules stacked together like giant toy bricks. Musk has literally compared the process to making Matchbox cars, just on a heroic scale. Once the press spits out 5 chassis in one go, they feed directly into the unboxed assembly flow. The line moves so rapidly and autonomously that humans cannot stand nearby while it runs. Because the mold is huge, molten metal must travel farther, raising defect risk. Inject too fast and you trap air, inject too slowly and metal freezes mid-flow. All this happens inside a press weighing millions of pounds and clamping at 50,000 tons. Naturally, Tesla needs months to transport, install, debug, and fine-tune such hardware before mass production. Other automakers, now scrambling to copy the idea, remain years behind. Most are only installing 6,000-ton presses. Thanks for staying with us through this deep dive. If you enjoyed the journey and want even more exciting EV stories, please tap like and share. Also remember to subscribe to AMP Drive and turn on notifications so you never miss fresh content. Your support means the world to us, and we can't wait to catch you in the next video. Goodbye.